Good evening, Team 8-1 Alley Cats. And should I say take two, meaning this is the second time that I've done this video this evening because the first time around deleted on me. So here I am. Actually, I didn't delete it, just the volume wasn't there. So some of you are saying, ooh, I like that idea. Anyhow, today we're going to be working with solving multi-step equations. So our I can statement is I can solve an equation that uses the distributive property and combining like terms and clears fractions and decimals. And I want to tell you guys about an excellent resource, which is page 126 in your book. So please feel free to look back at that if you need additional help. Here are the steps that we're going to use to clear an equation, or to solve for a variable, I should say. Step 1 says to clear the equation of fractions and decimals. That means if I see a fraction or if I see a decimal, then I need to get rid of it, and we're going to learn how to do that. Step 2, use the distributive property to remove parentheses on each side, which you guys already know. I think it's instinctual at this point that if you see parentheses, you know that you automatically multiply by whatever's outside of the parentheses to get rid of parentheses. Then, of course, if there are any terms that needed to be combined on the same side, then you would combine them. And then once you get to step 4, that's really where you have a two-step equation. And I think at this point you guys are really comfortable with solving two-step equations. So we're going to be referring back to this slide. Know that it's there and that you can use that as a resource as we're going throughout the problems. But really our focus is going to be that clear the equation of fractions and decimals, and then of course use the distributive property if I see parentheses. Problem number 1, we're just going to combine terms that are alike. So we're going to combine negative 2n and negative 3n. So I'm going to bring down 6, and then negative 2 minus 3 gives me a negative 5n. Make sure your equal signs are lined up, and we have a two-step equation. So I want to subtract 6 on both sides to get negative 5n by itself. Negative 5n is equal to negative 20. Divide through by negative 5 on both sides of the equation. So we end up with n is equal to positive 4. Now it does tell us to check our answer, so before I circle my answer and call it a day, I'm going to substitute in the 4 and make sure that we did this correctly. Remembering our order of operations tells me that it's more important to multiply than to subtract. So that means 6 minus 8 minus 3 times 4, or 12, which is equal to negative 14. How does that work? We end up with negative 2 minus 12, negative 14, and we did a good job. So I am going to go back up here and circle my final answer, put a box or a cloud or a heart or whatever you want to, just to kind of finalize your answer. On number 2, I see parentheses. So we haven't yet seen fractions and we haven't seen decimals, but we have seen on number 1 terms that I need to combine, and on number 2 we see parentheses. And the only way to get rid of the parentheses, my friends, is to multiply 5 times each of those values. So we end up with what? Positive 30 plus 5k. Line up your equal signs, is equal to 100. To get 5k by itself, I have to get rid of 30. And to do that, I'm going to subtract 30 on both sides of the equation. So we end up with 5k is equal to 70. Divide through by the coefficient of 5. And let's make sure that our final answer is 14. So I want to go back in my original equation and substitute in 14 for k. So we have 5 times 20, and that does check. K is equal to 14. Moving on to number 3. Now this is going to be where things are going to kind of change up for you just a little bit. You can see that there is a fraction in this problem, and let me make sure that you understand that you could do this problem by just adding 5/7 to both sides of the equation. But you understand that part of our I can statement is learning to clear the equation of fractions first, or if I were to see decimals, same thing applies. I want to clear the equation of decimals before I solve the problem. So in order to do that, here's what you need to find out. You need to know the LCD, or least common denominator, of 7, 7, and 7. Well, of course, the smallest number that 7 goes into is 7. So that's our least common denominator. And the purpose of the LCD is to use the LCD, multiply both sides of the equation by 7. Please get used to these parentheses because they're going to be very helpful. They're kind of an indication. We already know that when we see parentheses, we have to distribute. So that's why I really like parentheses instead of using a multiplication symbol. If I multiply 7 times a over 7, remember, here's just kind of a side note to you, that really means 7 times 1/7 a, because 1/7 a and a over 7 are the same thing. If you think about multiplying 1 times a, then I would have a over 7. So the reason I'm mentioning this right now is because if you're putting this in your calculator, you can't say 7 times a in your calculator, but you can say 7 times 1/7. And at the same time I'm saying that, you're probably thinking, well, I don't really need to put that in my calculator. I understand that 7 times 1 is 7, but also when I multiply by 7 and then turn around and divide by 7, all that I really have left is the letter A. Take some time to think about that. Not only do we multiply 7 by a over 7, but we also multiply 7 by negative 5/7. So same thing applies. If I multiply by 7 and then turn around and divide by 7, all that's left is negative 5. If I'm putting that in my calculator, 7 times negative 5, ABC 7, enter, all that's going to come out is negative 5. I hope that you get used to kind of doing that in your head. I think it's a little bit easier. And then on the right, the 7s will cancel. All that's left is 6. I didn't cancel on the left because I wanted to remember to multiply 7 not only by a over 7, but also by negative 5/7. And from here, you can see it becomes very easy. It's just a one-step equation. I end up with a is equal to 11. Now, let's see if that makes sense. If I go back and substitute in a for a in the original equation, I end up with 11/7 minus 5/7, which is equal to 6/7. So, of course, that does check, and we did a good job on number 3. So number 4 is a little different again. I see fractions. I see 8 as a denominator, and I see 4 as a denominator. As a general rule, and I want you to list this on your paper. Anytime you see a fraction, I want you to list the LCD, and I think that will help you to remember to multiply through by the LCD. Remember that magic word L, which is least. You really just have to find a number that 8 and 4 will go into. The advantage of finding the LCD, or least common denominator, is that you're going to keep your number smaller, thus making the problem a little easier to work with. So if I chose 16, that would be okay. If I chose 24, that would be okay. If I chose 32, that would be okay. If I chose 40, you get the point, because 8 and 4 go into both of those, or all of those numbers. But the least common denominator, wait for it, what is it? The least common denominator is simply 8. So a good starting place is, does 8 go into 4 or does 4 go into 8? And of course we know that they both go into 8. So we're going to follow that same guideline, and that is use big parentheses on both sides of the equation, multiply the left by 8 and multiply the right by 8. We want to distribute 8 times 4. That gives us a nice 32. And then 8 times m over 8. Now, what does that look like in my calculator? That's just 8 times 1/8. When I multiply by 8 and then turn around and divide by 8, all that's really left is m. Line up the equal signs. 4 goes into 8 2 times, and then 3 times 2 is 6. From here, we simply have a one-step. And for plus negative 26 over 8 is equal to 3/4. And you can check that in your calculator. It does work out. Remember the ABC key when you have a fraction like negative 26/8. So it looks a little scary kind of up front when you choose the LCD, but really you can see once you do that, it makes a very nice and easy equation. Sometimes it's two-step, but in this case for number 3 and 4, it was simply a one-step equation. So now the question is, what do we do when we have decimals? Remember that first step is to clear the equation of decimals. So the question is, well, how do you do that? Well, the number that where you would have to move the decimal the most amount of places to make it a whole number, that's going to be kind of the boss of the whole situation. Because I can't just start multiplying by 10 and multiplying by 100 or multiplying by 1,000. Whatever number I choose, I have to multiply all of the numbers by the same number, being the multiples of 10, 100, or 1,000, or it could be 10,000, so that we keep it proportional. That's the only way the problem is going to work. So I see that in 24 and 2600ths, in order to make this a whole number, I would have had to move the decimal 2 places. In 2 and 452 thousandths, I would have had to move it 1, 2, 3 places. And then 75 and 2400ths, I would have had to move it 2 places to make it a whole number. So of course, you may have guessed it, ding, ding, ding. That would be the winner. I have to move the decimal a total of 3 places. And once again, you have to be consistent. If I choose to multiply by 1,000, or moving the decimal 3 places to the left, to the right, then I have to do that, and I have to make sure I'm consistent with all the numbers. So with 24.26, I'd have to move it 1 more place, making it 24,260. Don't forget the X. We already know that that's going to be our whole number because it was the winner, it's the boss, it's the one that made me move it the most amount of places. And then the last one would be, have to add 1 more, so that would be 75,240. So in other words, we multiplied by 1,000 on both sides. Here's a good way to show your work. Big parentheses. We chose to multiply by 1,000 on the left. We chose to multiply by 1,000 on the right. Going back to the original number. Now, what if you chose to multiply all the numbers by 10 or all the numbers by 100? You would still get the right answer, but you wouldn't get full credit for this problem because you didn't eliminate the decimal. So that's kind of the idea up front. From here, we just have a 2-step equation. And then 75,240 minus 2,452 looks like 72,788. Divide through by your coefficient. So the coefficient is always the number in front of the variable, no matter how big or small it is. In this case, it's fairly large. And all that's left is 3.0003, and I believe after it really was a 2, I just went ahead and rounded to the 10,000ths place. Now, you might be saying, well, how do I know how far I should go out? Well, I just didn't want to leave this as decimal 000. I wanted you to know that there was another number after that. That's going to take care of it for solving multi-step equations with clearing fractions, decimals, and using the distributive property, combining like terms. Have a great evening.